A curious child asks, "Why do apples fall from trees?" A reasonable adult answers, "Because of gravity." At first glance, that explains it. Case closed, right? But our child isn't satisfied. Why is there gravity? Why do masses attract each other? Now the conversation gets tricky. A Newtonian might respond, "Masses attract via an invisible force. It's just how nature works." Newton himself admitted he had no idea why gravity obeys an inverse square law. He famously wrote, "I have not been able to discover the reason for these properties of gravity, and I frame no hypotheses." In other words, don't ask me why gravity exists. I can only tell you how it behaves. To Newton's credit, he gave us an equation to predict gravity's pull, but even he shrugged at the deeper why. Fast forward to 250 years. Einstein explains gravity by saying mass curves spacetime. Cool! Now we know how gravity works in a geometric sense. But if you ask, "Yo Einstein, why does mass curve spacetime in the first place?" Physics goes silent. There's no deeper reason offered. Mass just does that, according to general relativity. We replaced one magic with another magic, and each is just as arbitrary at the core. As physicist Sabine Hossenfelder puts it, sometimes the only scientific answer we can give is we don't know. Maybe gravity's too esoteric. Let's try electricity, something closer to daily life. We learn that opposite charges attract. Why do opposite charges attract? A textbook might say, because of the electromagnetic force, unlike charges, have an attractive Coulomb force between them. Okay, so there's a law describing that attraction. But if we're cheeky, we ask, why do they have an attractive force? At this point, an expert might invoke an even fancier idea. Opposite charges lower the system's energy. When together, systems seek a lower energy, a balance. So plus and minus charges want to neutralize. But hang on, why do systems seek lower energy or balance? Because of the second law of thermodynamics, tendency toward maximum entropy, minimum free energy. Great, we've taken one step deeper. So why does that law hold? See where this goes. We either end up in an infinite loop or back to just because. In practice, a physicist might level with you. That's one of the fundamental forces in the universe. It just exists. Nothing exposes the limits of understanding quite like quantum physics, the wild playground where our intuitions go to die. We're told that a particle can behave like a wave, that it can be in superposition, multiple states at once, until observed, and the two particles can be entangled, so that poking one instantly affects the other, even across light years. Why does the quantum world behave like this? Enter the Hall of Mirrors. If you ask a physicist, why do quantum particles only give probabilistic outcomes instead of definite ones? The honest answer is, that's just how nature works at that scale. We have highly successful equations, the Schrödinger equation, etc., that predict probabilities with insane accuracy. But why those equations? Why isn't the world deterministic and classical? Consider the famous double-slit experiment. Shoot electrons through two slits and they create an interference pattern like waves. Unless you observe them, then they act like particles. Why does observing, or measuring, change the outcome? Because the quantum wave function collapses upon measurement, a physicist might say. Okay, but why does it collapse? Is it consciousness? Parallel worlds splitting? Are the electrons aware of being watched? At this point, physics textbooks usually go silent or divert into philosophy. At some point, physics becomes metaphysics. We stop talking about measurements and start talking about meaning. We stop with equations and start questioning why those equations, or why a universe at all. As Stephen Hawking famously pondered, even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? Hawking's rhetorical questions hit the nail on the head. A theory of everything might give us beautiful equations uniting all forces. But it won't tell us why those equations exist or why there is a universe governed by them. Indeed, questions like, why is there something rather than nothing? Or, what caused the Big Bang? Might be forever beyond empirical science. Here's a quirky observation. About 97% of Wikipedia articles, if you click the first link in the article text and repeat, eventually lead to the article on philosophy. So, is physics just stupid because it can't explain why the universe is the way it is? Of course not. Our provocative claim was a sarcastic challenge, not a serious dismissal. Physics is brilliant at doing what it's meant to do, explaining how things work and predicting outcomes within the framework of natural laws. It's uncovered deeper and deeper layers of reality, from gravity to electromagnetism to quantum mechanics. But it's also honest, when prodded, about its limits. There's a quote often attributed to the physicist Carlo Rovelli. It is hardly surprising that there are more things in heaven and earth, dear reader, than have been dreamed of in our philosophy or in our physics. In other words, the universe will always have mysteries that lie beyond the current reach of our explanations. So the next time you drop your pen and it falls, you can credit gravity and feel smart. Just remember, if someone annoyingly asks, yeah, but why does gravity exist? You have two choices. Pat them on the head and say, it's just physics, my friend. Or invite them down the rabbit hole of endless whys. Physics isn't stupid, but it does have a sense of humor about our quest for certainty. It tells us a lot about how the world works, but when we demand to know why this world at all, physics mischievously grins and says, that's above my pay grade. Thanks for watching. Don't forget to like, share, and subscribe if you want more deep dives like this.